In section 4.3, we are going to be solving quadratic equations by factoring. We're going to solve quadratic equations by factoring, and then we're going to solve a higher degree polynomial equation using factoring. Specifically, we're going to solve a third degree polynomial equation by factoring by grouping, and then we're going to solve a problem using quadratic equations. All right. What do Angry Birds and algebra have in common? And this is a game that was fairly popular, 20 or so years ago, where you would catapult your bird into the air and hopefully hit the pigs. And it's a game that I was not particularly good at, even though there is a relationship between the bird and algebra. And the relationship is that the catapulting birds are projectiles. And on planet Earth, the path of a projectile, as well as their heights over time, can be modeled by quadratic equations. So I took my Angry Bird and I took the image and I put it in the TI Nspire application and had the TI Nspire application give me an equation that modeled the path of my bird's trajectory. And that equation you can see there on the screen. The equation is that y, so we're in the coordinate plane, so y, the vertical axis, is equal to negative 0.13x squared plus 0.077x plus 8.03. And this is a quadratic equation. And the reason it's a quadratic equation is that x squared right there. So if you have an equation that has a variable raised to the second power, and there are no other variables in the equation being raised to a larger power, so the biggest exponent on any one of the x's is the number 2, that's a quadratic equation. So this quadratic equation, because it has an x squared in it, is the trajectory of this bird. It models the path of my Angry Bird. So the definition of a quadratic equation is as follows. A quadratic equation in X is an equation that can be written in the standard form ax squared plus bx plus c is equal to 0. A, the coefficient on the x squared, b, the coefficient on the x, and c, the constant, are all just real numbers, and a cannot equal 0. If a were equal to 0, then the x squared term would disappear and you'd end up with a linear equation. So you have to have a non-zero coefficient on the x squared. A quadratic equation in X is also called a second degree. The biggest exponent on any one of your variables is the number 2. So it's a second degree polynomial equation in X. And you might notice that this equation, ax squared plus bx plus c, is equal to 0. So from our Angry Bird model, we're going to set y, which is the vertical location, we're going to set that equal to 0. What's that mean? Well, that means we're going to find where my bird hits the ground. If y is equal to 0, we set this equal to 0, then that is on the x-axis. So if you have y is equal to 0, you are sitting on the x-axis. So that is this point over here where we cross the x-axis, or it could be this point over here on the left where we cross the x-axis. So you could, from this model, get two different values of x where this bird is hitting the ground. Since we're launching the bird from here, what we're interested in is where it hits the ground over here. And do we care where it hits the ground? Do we ever care when we launch something up in the air where it hits the ground? Maybe. Do you think they cared where he hit the ground? Of course they did. Do you think they modeled this jump before he ever did it? Of course they did. Where he hits the ground is of utmost importance because if he misses where he's supposed to hit the ground, it can be disastrous. This particular jump was done by Evel Knievel Jr. He jumped the fountain at Caesar's Palace in Las Vegas, and he's not the first person that's jumped the fountain at in Las Vegas. I can't talk. His dad did the same jump, and his dad missed. So where you hit the ground can be very, very important because his dad was seriously injured when he missed the jump. Okay, so we're going to use what is called the zero product principle to solve quadratic equations. The zero product principle states that if the product of two algebraic expressions is zero, so you're multiplying two algebraic expressions together, and the product you get is the number zero, then one of those factors has to be equal to zero. Whenever you multiply two things together and one of the factors is zero, then the product's going to be zero. So if the product is equal to zero, one of the factors must be zero. So if A times B, where A and B are both algebraic expressions, is equal to zero, then either the algebraic expression A is zero or the algebraic expression B is equal to zero. One of them has to be zero. So we use this to solve a quadratic equation. And here's your steps. Step number 1, if necessary, rewrite the equation in the standard form, ax squared plus bx plus c is equal to 0. So you want 0 on one side of the equation and everything else on the other. Then you factor your algebraic expression completely. Then you apply the zero product principle by setting the factors equal to 0. Then you solve the equations you got from step 3, and then you check your solution. So let's solve a quadratic equation using the zero product principle and factoring. So step number 1 is that we need to get this quadratic in standard form. So standard form is ax squared plus bx plus c is equal to 0. So I have a 12 on the right-hand side of this equation, so I need to move it to the left to get it in standard form. So I'm going to do that by subtracting the 12 from both sides. So I subtract it from the right-hand side, I subtract it from the left-hand side. So 12 minus 12 is 0 on the right. On the left, I have 2x squared minus 5x minus 12. So I'm going to factor the trinomial on the left-hand side of this equation. I'm going to factor this to the product of two binomials. And the way I factor this is I am going to look at the first term in the trinomial. And in the first spots in my binomial, I'm going to put factors of the first term in my trinomial. So in the two yellow spaces, I'm going to put factors of 2x squared. And for this particular example, in this particular factorization, we want to factor this to 2x times x. We always want an x in each of the binomial factors. That's the only way this thing is going to FOIL and give us a correct trinomial. So we're going to put 2x here, and we're going to put x here. Now, in my last spot, in my trinomial, I have negative 12. So I'm going to put factors of negative 12 in my green spots. Okay, so what are some factors of negative 12? Negative 12. Well, it could be negative 1 times 12. Or it could be 1 times negative 12. Or it could be what? 6 times negative 2, or negative 6 times positive 2, or 4 times negative 3, or negative 4 times 3. And I suspect it's going to be one of these. That's my gut feeling, my suspicion. So I'm going to put factors of 3 and 4, negative 3, positive 4, or negative 4, positive 3 in those spaces. And then I'm going to do a quick FOIL to see if it works. Now my suspicion is a 4 here, a 3 here, a minus here, and a plus here. Am I right? Am I correct? All right, so let's see. To be able to test this, I FOIL it. So I'm going to do inside, which is 3x. I'm going to do outside, which is negative 12x, and that is not correct. Oops, yes it is. I can't multiply. Is that negative 8x? Yes it is. Yes it is. And when I add those together, when I add 3x and negative 8x, I get negative 5x, which is the middle term. So that is the correct factorization of that trinomial. If I FOIL it, 2x times x is 2x squared. Outside is negative 8x. Inside is 3x. Negative 8 plus 3 is negative 5x. 3 times negative 4 is negative 12. All right, that was step 2. Step 3 and 4 we're going to do together. We're going to, from the zero product principle, set each of those binomials equal to 0. That's step 3. And step 4, we're going to solve each of those equations. So I'm going to subtract 3, get the 0 in there, subtract 3 from both sides, divide both sides by 2. So negative 3/2 is one possible solution. I'm going to add 4 here, add 4 here. X is equal to 4. So my two solutions are negative 3/2 and 4. And the way you input this into MyLab they'll give you the braces to show you that this is a set. You type in the solutions separated by a comma. So I would type in negative 3/2, then comma, and then type in the 4. All right, the next step is to check to make sure those are solutions to my original equation. So I'm going to substitute those two solutions back in the original equation, negative 3/2 and 4. And the original equation was 2x squared minus 5x equal to 12. So I'm going to check negative 3/2. So I'm going to put the negative 3/2 in for x. And I highly recommend you let your calculator do this. There's no reason why it can't do this calculation for you. And I want to see, am I going to get 12? Okay, so we're going to square the negative 3/2. When I square a negative, I get a positive. To square a fraction, I square the numerator. 3 squared is 9. 2 squared is 4, and I'm multiplying that by 2. Then I have a minus, that's going to give me a plus. 5 times 3 is 15, 15 over 2. The first term, the 2 will cancel. I end up with 9 halves plus 15 halves. 9 halves plus 15 halves is 24 halves, which is 12. So negative 3 halves is a solution. Now let's check the 4. Put the 4 in, and again, is there any reason why your calculator can't do this? Of course not. So we get 2 times 16 minus 5 times 4 is 20. 32 minus 20 is 12. So 4 is also a solution to this equation. All right, let's solve this one. Now you might note that in this particular quadratic equation, it is a quadratic equation because of the x squared. That's what makes it quadratic. But there's no constant in this equation, no constant. It only contains two terms that contain a factor of x. So we're going to factor this a little bit differently than we did the last problem, but we still got to move the 20x over there on the left. So let's subtract 20x from both sides. So on the left, I have a 5x squared, and I have a minus 20x. On the right, 20x minus 20x is 0. So I'm not going to factor this into a product of two binomials because there's no constant. I'm going to factor a greatest common factor. So the first thing I look at is the coefficients. I have a 5 and a 20. What is the biggest number that will divide into both 5 and 20? And that would be 5. Then we look at the variable factors. I have an x squared and an x to the first power. You can always include the variable of lowest degree, smallest exponent, in your GCF. So our GCF is also going to contain an x. So we're going to factor this into its GCF times the remaining binomial. So how do we figure out what's inside these parentheses? We take each one of the terms above and divide it by 5x. So take the 5x squared and divide it by 5x. 5 divided by 5 is 1. X squared divided by x, we subtract the exponents, we get x to the first power. So we put an x right there. And then we check, does 5x times x equal 5x squared? Yes. So the first term in that binomial is good. Then we take the minus 20x, we divide it by the 5x. The result will be negative because we have a negative divided by a positive. 5 will go into 24 times, minus 4. X divided by x is 1. So we get a term of negative 4. So does 5x times x minus 4 actually multiply to 5x squared minus 20x? And the answer is yes. 5x times x is 5x squared. 5x times negative 4 minus 4 is minus 20x. All right, so that is step 1. We factored it completely. Step 1 and step 2. Step 3 and 4, we're going to set each one of these factors that contain a variable equal to 0 and solve the resulting equations. So we take the 5x, we set it equal to 0, we take the x minus 4, and we set it equal to 0. Divide by 5 here. 5 divided by 5 is 1. 0 divided by 5 is 0. Add 4 here. Add 4 here. X is equal to 4. So the two solutions that I get are 0 and 4. And I am going to check those real quick. I'm just going to plug in 0 for x. If I plug in 0 for x, the left-hand side is 0, as is the right-hand side. If I plug in 4, 5 times 4 squared, is that equal to 20 times 4? 5 times 16 is, of course, equal to 80. So both of those solutions check. They are the solution to that equation. Now, the other thing that your text does at this point is it graphs this quadratic equation. And I think that's a really good idea to show you what this thing actually looks like. You could use Desmos. I'm going to use the TI-84 calculator. If you own a TI-84, you can use it for graphing purposes. Desmos works very, very well. Desmos.com. I guess I could write that down. Desmos. The only thing with Desmos is you can't use that on a test. But to get an idea of what this looks like, it works very well. I'm going to use my calculator. So I'm going to go over and find my calculator. And I'm going to type in that equation. And I do need to type it in when I solved it or got everything over on the left. So I'm going to type in the left-hand side. Y equals, it was equal to 5x squared minus 20x. And I'm going to do a zoom standard number 6 because that sets the TI-84 window in the x direction from minus 10 to positive 10 and in the y direction from negative 10 to positive 10. So it sets my window to standard. So do zoom 6. And there we go. That is the graph of that quadratic equation. Now I can't see the bottom of this, so you can't really see what it looks like. So I'm going to adjust my window, and I'm going to make my y min negative 30. So maybe I can see the bottom of this thing. And then graph it again. And there you go. So this is the standard shape of the graph of a quadratic equation. It's called a parabola, and it has this bowl shape. And as you recall from our Angry Bird example, that was parabolic also. It was just a parabola that opened downward. So you see the trajectory on planet Earth is this parabola that opens down, and this is a parabola that opens up. It holds water, where the projection of that Angry Bird would lose water. And the reason it looks that way and not the way the Angry Bird example looked like is the coefficient that's on the x squared. If you recall from our Angry Bird example, the coefficient on the x squared term was negative. So it has this shape that opens down. In this example, our coefficient on our x squared was positive 5. So you get this shape that opens up. You can also see that this parabola crosses the x-axis through the origin. It also crosses the x-axis at 4. Well, those were our solutions to our quadratic equation. X equals 0, which is the origin, is a solution, and x equals 4 was also solution. So the solutions to our quadratic equation are the x-intercepts of this parabolic equation. It crosses the x-axis at x equals 0. It crosses the x-axis at x equals 4. All right, let's go back to our PowerPoint. Let's solve this quadratic equation by factoring. So step number 1 is that we need to get everything on the left-hand side and 0 on the other. So I'm going to subtract 8x from both sides. So on the left-hand side, I have an x squared. I have a minus 8x. I have a plus 4. On the right-hand side, 8x minus 8x is 0, and I have a minus 12 left over. Now I'm going to add 12 to both sides. And I lined it up this time. The 4 and the 12, I lined those up because I am going to add those two like terms. 4 and 12 is 16. 12 minus 12 on the right-hand side is 0. Now I'm going to factor this. So I'm going to factor it again into the product of two binomials. I have an x squared in the first term of my trinomial, so I'm going to factor that to x times x. So I'm going to put an x there and an x there. Again, this is x squared. These need to be both x. And then I'm going to look at the factors of positive 16, and I'm going to put those right here. Since that last term is a positive number and the middle term is negative, they both need to be negative. The last term is positive, but the middle term is negative, so both must be negative. When I do outside and inside, I'm adding two negatives. I'll get a negative, but when I multiply last, negative times negative gives me positive. So I need two factors of positive 16 that add to negative 8, and that is going to be, or add to 8, that's going to be 4 and 4. And they're both going to be 4. So if I FOIL this, outside's negative 4x, inside's negative 4x, negative 4 times negative 4 is positive 16. Now I set each factor equal to 0, and you might note that they are the same factor. This is actually a perfect square trinomial, and a perfect square trinomial factors to a binomial squared. So they are going to be the same factor. So I'm going to add 4. I'm going to add 4. I get x is 4 from both of those. So I get one solution, but it's called repeated. It's a repeated solution. It actually has two solutions. 4 is repeated twice. It's the way we say that. Okay, now if I were to graph this again, I could see what's happening with my parabola, my quadratic function. So let's go over and graph this. Well, didn't get to my calculator. There we go. There we go. All right, so I'm going to go to my y equals, and I'm going to type in x squared minus 8x minus 8x plus 16. And what have I done? I have no idea what I did. Let's try that again. Wasn't looking at what I was doing. Try this again. 8x plus 16. And I'm going to again do a zoom 6 just to set the window to standard. And there you go. So again, this is a parabola that opens up, and you can see that it's touching the x-axis at 4. Since this is a repeated solution, repeated twice, that's exactly what that parabola is going to do. It's going to touch the x-axis at that point. So the solution to the equation was x equals 4. The x-intercept here is also equal to 4. All right, what about this one? Oy vey. Okay, to do this one, we have a little bit of work to do to get this in standard form. So we do need to put this in standard form. So we need to get a polynomial on the left-hand side and 0 on the other. So the first thing we need to do is we need to multiply this out. We need to FOIL this. And that's going to be equal to -20. But we do need to multiply that binomial times that binomial so that we can attempt to get it in standard form. So we're going to multiply first x times x. We're going to multiply outside x times +5 plus 5x. We're going to multiply inside -7 times x -7x. And then last, -7 times +5, -7 times +5. So we get x squared plus 5x minus 7x minus 35 is equal to -20. Let's combine those like terms. 5 minus 7, the difference between those two numbers is 2. The 7 is bigger, it's negative, so we make that -2. X squared minus 2x minus 35 equals -20. Lost my 0 there. Add the 20 to both sides. And we finally get a trinomial we can factor. A trinomial that is in standard form. -35 plus 20. The difference between 35 and 20 is 15. 35 is bigger, and it's got a negative in front of it, so it's -15. Okay, so now we're going to factor that. It's going to factor to a binomial times a binomial. X. And we have 15 as our last, or excuse me, -15. So we need two factors of -15 that add to -2. I'm thinking that's -5 and 3. So x minus 5, x plus 3. Is that correct? Let's FOIL it real quick. X times x is x squared. Outside's 3x, inside's -5x. That adds to -2x. -5 times +3 is -15. So take each of these binomial factors and set them equal to 0. Add 5 here. X is equal to 5. Subtract 3 here. X is equal to -3. So 5 and -3 are our solutions. And we do a quick check there. If I put the 5 in, I get -2 times 10 is -20. If I put the -3 in, I get -10 times 2 is -20. So both of those check. And if we graphed it, we could see that this parabola crosses the x-axis at -3 and +5. So the x-intercepts are at -3 and +5. All right, let's factor something that's not quadratic. We have x to the third plus x squared equals 4x plus 4. So this is not quadratic. It's not quadratic because of that x to the third term. That x cubed term makes this not quadratic. But I did learn a technique in section 4.2 for factoring third degree polynomials with 4 terms. And that's factoring by grouping. So that's what I'm going to do. I'm going to factor by grouping. So I do need to get it in a standard form. I need to get 0 on the right-hand side. So I'm going to subtract 4x from both sides. So over on the left, I have an x to the third. I have an x squared, and I have a minus 4x. On the right-hand side, 4x minus 4x is 0, plus 4 is 4. Now I'm going to move the 4 over, subtract it from both sides. So now I have x to the third plus x squared minus 4x minus 4 is equal to 4 minus 4 is 0. To factor by grouping, I need to group the terms together. So I'm going to group the first two terms together. I'm going to group those together. And I'm going to group the second two terms together, the minus 4x and the minus 4. And then I'm going to factor both of those groups by factoring a common factor from the two groups. So looking at the first group, I have an x to the third and an x squared. A common factor would be x squared. I can always factor the variable of smallest exponent out. So I'm going to do that. If I factor an x squared from x to the third divided by x squared is x. If I factor an x squared from x squared divided by x squared is 1, so that is plus 1. And do a quick distributive law. X squared times x is x to the third. X squared times 1 is x squared. Now the second two terms can be a little tricky. I see that there's a common factor of 4 in those two terms, but I note that they're both negative. So if they're both negative, I am going to want to factor out a negative. As a matter of fact, if the first term is negative, you're going to want to factor out a negative. Okay, so what happens if I factor out negative 4? I have negative 4x divided by negative 4. Negative 4 divided by negative 4 is 1, so I get an x here. Negative 4 divided by negative 4 is 1, so I get a plus 1 here, which is exactly what I wanted to happen, because I want those binomial factors to be exactly the same thing. So now I'm going to factor out the x plus 1. So I'm going to factor the x plus 1 from each of those factors. So I'm going to factor it here and here. And what do I have left when I factor it out? I'm going to have x squared minus 4 in parentheses when I factor out the x plus 1. So let's factor it out. X plus 1 times x squared minus 4. This is the difference of two squares. The difference of two squares factors to a sum of the square roots times the difference of the square roots. So that's going to factor to x plus 2 times x minus 2. The square root of 4 is 2. And then you set each of those three factors equal to 0. X plus 1 equal to 0. X plus 2 is equal to 0. And x minus 2 is equal to 0. Subtract 1 here. We get x is negative 1. Subtract 2 here. We get x is negative 2. Add 2 here. And we get x is 2. So the solutions are negative 1, negative 2, and positive 2. And I could do a quick check of that. All three of those will check just fine. If I put negative 1 in, I get negative 1 plus 1 is 0. Over on the other side, negative 4 plus 4 is 0. That works. Negative 2, negative 8 plus 4 is negative 4. Negative 8 plus 4 is negative 4. And then 2, 8 plus 4 is 12. On the other side, 8 plus 4 is 12. So all three of those check. All right. How can we use this? Well, we showed at the first of this lecture that the trajectory of birds, angry birds, in the game Angry Birds, that trajectory can be modeled using quadratic equations. So we're going to look at the motion of a ball. So you throw a ball straight up from a rooftop 384 feet high with an initial speed of 32 feet per second. The function s of t equals negative 16 t squared plus 32t plus 384 describes the ball's height above the ground, s of t in feet, t seconds after you throw it. The ball misses the rooftop on its way down and eventually strikes the ground. How long will it take the ball to hit the ground? Well, it's going to hit the ground when the height is 0. So when s of t is 0. Thus, we substitute 0 for s of t in the given function and solve for t. And this is a typical motion model on the planet Earth. This minus 16 is 1/2 the gravity on planet Earth, the force of gravity, which is negative 32 feet per second squared. So half of that is negative 16. That is the force of gravity that holds us down on the Earth, that negative 32 feet per second squared, the acceleration of gravity. So we're going to take this function and we're going to set it equal to 0 because it hits the ground when s of t is equal to 0. So you've got a coordinate plane where you've got time on the horizontal axis and the height of this object on the vertical axis. So I'm going to factor out a negative 16. I think this will just make this way easier to factor. And since that leading coefficient is negative, I am definitely going to factor out a negative, because I like my leading coefficient in the trinomial that I'm factoring, I like that to be positive. Okay, so I have 16t squared. I'm going to divide that by negative 16. That is going to be t squared for the first term. And yes, negative 16 times t squared is negative 16t squared. Then I'm going to take the 32t, and I'm going to divide that by negative 16. 32 divided by 16 is 2, but it is negative because we're dividing a positive by a negative, so that's going to be minus 2t. Then take the 384 and divide that by negative 16. Take your handy-dandy calculator out and do that, and that's going to be negative 24. Okay, so now I'm going to factor the trinomial. So negative 16, I'm going to have t's here, and I need factors of negative 24 that add to negative 2, and that's going to be what? Negative 6 and positive 4? Negative 6 and positive 4. Set each of the factors that contain a variable equal to 0. You don't set the negative 16 equal to 0. It's negative 16. It's not going to be 0. But you set the t minus 6 equal to 0. You set the t plus 4 equal to 0. And then solve. And in the context of this problem, time equal to negative 4 does not make sense. If time is negative, that's in the past. The past is the past. It is what it is. We're only interested in the positive solution, positive 6, because when we throw this ball up in the air, 6 seconds later, it's going to hit the ground. This is a solution to the quadratic equation. It is not a solution to our real life model. The solution to this is t equals 6. So 6 seconds after you throw that ball up, it's going to hit the ground. I thought we had a picture, but I guess we do not. All right, if you have any questions, be sure to reach out to me and send me an Ask My Instructor when you're doing your homework. If you haven't done your factoring homework, get on that right away.